All right, welcome everyone to the Hacking in Earth and Earth Engine session. It's the end of the day, well, end of the conference. We're going to have a little fun here today, play around with a few fun things. Some of it's a little silly, some of it might be useful. Hopefully you get some inspiration and a little bit of entertainment out of it as well. Let's see. My name's Christiaan Adams. I'm a developer relations engineer on the Earth Outreach team. I help folks with Earth, a bit of Earth Engine, imagery, crisis response, a whole bunch of things. I have a couple friends here today. Gennadii has been a long-time Earth Engine power user and recently joined Google on the cloud team, helping Earth Engine users on the commercial side. And anything else you want to say?
No, it's fine.
Okay.
I will say shortly.
Great. And David has been one of the outreach team's go-to developers for both ourselves as well as partners who are looking for somebody that can create awesome KMLs and Earth experiences and stories and things like that. And he is based in Ireland. Yep. So let's see. Today we are going to talk a bit about some Earth Engine stuff that Gennadii's going to show you, some fun things. I'll talk a bit about the transition from Earth to Earth Engine into Earth, how you can bring data in, and then David will take you through how to use that in Google Earth to do some fun storytelling techniques. And then hopefully we'll have plenty of time for Q&A. So let's get started. I think it's you, right?
It's mine.
Yes, OK.
Okay, let's get to the laptop.
I'll pray to the demo gods.
And see if we can get these things rolling. Not sure if audio will work. No, it's not. Okay, it's fine.
Oh.
We hear music. Oh, let's start rolling. Okay. Hi everyone. So in this session, or this first part of the session, so what I'm going to show is some things what you should not be doing with Google Earth Engine, or you can do actually with Google Earth Engine. And you see this some animation, some fun rotated image. For GIS people, it's not really something you would expect to do, like take Landsat image and start turning it around. But I was like, just while working mainly on my PhD, I was like, sometimes you have to think hard about your research, and then you basically start procrastinating when your research doesn't go well. And then suddenly you create some things like, OK, I can do this with Earth Engine, and it should be possible. And then why not? But after some point, sometime when you implement this thing like animating dino or rotating image, you start thinking, oh, OK, can I use it actually for serious applications? And then you jump to things like you applying the same techniques to more serious, let's say, uses of Earth Engine. And then you start realizing that, OK, this is what lacking in Earth Engine, Google Earth Engine. So like adding palettes or trying to project image collection more in horizontal kind of space, in gridded form, something which probably would be more logical to do in Python. But yeah, if you could do it in code editor quickly, so that's really help me to quickly, let's say, make this figure to printed copy in a paper, for example. So that's what we will be covering today during this session. And over time, let's see if I can. So today we will have a look at few of these kind of packages. So these scripts are available as packages that anyone can use. It's open source repository. So look at how we can animate image collection, how we can show image collection more in 2D grid form, and how we can add labels to in Google Earth Engine. So several like scripts built on top of standard Google Earth Engine API. And these all packages are also available on GitHub. So you'll get link to the presentation, to slides. I think let me jump. If you want to follow along this presentation, then you can go to bit.ly G2G22-hack Earth slides, and then you will get the same slide deck and can click on links and scripts in this presentation. So let's jump back. And once you go on GitHub or click on this link below, then you will get basically all the scripts with some examples in your repository and can just run and test. And not all of them are working, so I have to warn you that these are really like prototypes, but those scripts which are useful, then I try to not to change them, to keep them backward compatible. So if anyone uses it, it will always stay there. And so let's look first on the first part, or first example is called animation. So basically I realized that when you work with time-dependent images or image collection in Earth Engine, it's what I was really missing is to do like eyeballing, what's called, that you want to look at your data, and because Earth Engine is really powerful when you work with time-dependent data or with like multiple rasters, image collections, so then you really want to kind of swipe over image collections and look at different images at different times, and then filter cloudy images, and then again repeat this. So I was really missing this functionality, like not exporting videos, but you really want to do it now, and then I built this package. So you could basically import the animation or call it whatever you want as some imported via require. And then once you have image collection, you could specify visualization parameters and just call this function animate. And what it will do, it will basically add a number of image layers from image collection as layers in the map. And then you could just run the animation like what you see here, or you could also swipe, so there are some controls will be shown that you could go back and forth and really explore your images very quickly. And so here we see a more serious application, not like previous one with Dino, and that shows NO2 concentration over some different, I think, days over the world, and that's coming from Sentinel-5 satellites. And then here another example zooming into Antarctica, and I think it's like goes for 2 months probably interval. So these are examples what you could do with this animation package. Here's another example. So I'm actually my office is somewhere here up in Amsterdam, and then you see here North Sea, which doesn't have islands, but when we look at at Sentinel-1 images which are coming from SAR sensors, and you would see that a lot of activity in this North Sea. And then with this animation package, you basically can very quickly explore these changes. So, and just to jump also to script. So here I have in the top, so this is the GitHub repository that you can access via this link from slides. And here I also open the scripts and like pre-rendered. So it's some of them, it may take some time to run, but you basically will be able to just open any of the scripts from the presentation. And also, like, if you're interested, really look in the source code. So how the hell is this working? And so here's example with this Dino. So what I did, I basically took animated GIF and split it into 7 frames images, imported into Earth Engine. Yes, a question?
Sorry to interrupt. I know a few of us can't access the slides, so the link wasn't working.
Maybe something we can check on.
Did you get the bit.ly link for the slide deck? It's not working? Correct. Okay. I'll make sure to get that fixed.
Yeah. So it's a G for G. So you. Okay. So just opening one more time. So it's a bit.ly /
Didn't I?
hack. You know, it's a hacking session. So you have to try different combinations. And one of them will be working.
True hackers got that one, right?
Okay, let's get back to Dino. So, so how is this, for example, how this example is working? So I basically took animated GIF and then converted it into just images. Then what I saw is that, you cannot just take any image ingest in Earth Engine. So you have to take Dino image and assign some projection coordinate system to it first. Once you do it, then you can import any image as just image collection asset. And the only thing you have to do to make it move is to add time, and basically for every frame you would have to just shift your image and reproject, and then you have this kind of fun. You can play with it back and forth. And,
But should your projection deform the dinosaur?
you could. I think that we could stretch it into like stereographic on Earth, flattened dino running around Earth. Let's try it. But getting back to more serious examples, so here is also this NO2 example. I could not find script with the same colors as before, but I also built an app some time ago where you could, so it's using Earth Engine apps where you could look at this data from like mean value of NO2 concentration or stretch it to the current map and then also look at how it looks like and even like click at specific point and then you will get after some time series of NO2 concentration. So these things are really easy to do with Google Earth Engine. Yeah, here's the same example with ice moving. And yeah, it's like, I really like to, so when you have animated GIF or export video, it's you cannot really swipe back and forth. So you, as a scientist, you're really interested, okay, when does this iceberg move or piece of ice? And you really want to explore your data and have very quick, let's say, feedback. Okay, so that's one part. And then let's quickly run over other slides. So from animation to gallery. So in the same way, so sometimes when you're exploring data, you want to look at this data as animated, but when you want to publish it or copy it somewhere, you want basically to take your images, which are stacked, and just flatten it in some grid, rows, columns, and that's what this package is doing. So basically it allows you to take any image collection, specify number of rows, columns, and regions that you would use to clip your, let's say, first image or all images, and then it will shift all images within your image collection in X, Y rows. So I think, I don't remember, I think it goes like row, column order. And that's appeared to be useful also for some applications. So you could find this link to this script. Like here, when I click on this point, I basically built a buffer around this point first, and then kind of compute bounds of this buffer. So you would get this square. And then once you pass this image collection with this parameter, this region as an argument, then it will basically flatten your image collection. And yeah, for GIS people, this would look like very weird, like why would you shift this? But I want this to screenshot this image or export it, and then this becomes useful tool. And it's a bit hack technique that just reproject. It's a one line of code to do in Earth Engine, but yeah, it's the think out of the box to kind of make use of, make this type of application. And so then another script, which is actually, this gallery, it was not used a lot, but something like palette, it was extremely, I found it that people use it a lot because in Earth Engine standard, like different predefined color palettes were missing. So I built a package where you could use more kind of expressive colors from different predefined libraries. And here you could see that also another link which goes to GitHub where Justin Bratton, another colleague of Google, even spent time to really build, to describe, write documentation on this package and also listing all these color palettes. So if you follow instruction in this guideline, you will be able to add really nice colors to your visualization within Earth Engine. And so next package is a text. This is also was one of the missing functionality in Earth Engine. And frequently you want to just not show image, but you want to export image with labeling maybe date or other text. And internally, it's really hacked together. So I had to take the same as with Dino. I had to take bitmap fonts as an image, import into Earth Engine, which you could see example here for specific fonts. And you have to cut your image of fonts for every text string. So and turn your text strings that you pass in as an argument, compute ASCII code of an image, compute offset in this image, cut it out, and then glue together. So this is how it works internally. But from a user point of view, you have a text, you have a point where you want to draw this text, and you pass string as an argument, coordinate, scale, font size. There are just only predefined font sizes supported, and then it will be rendered as a text. So what you see above. So that's from user point of view, it's really very, very simple to use. And yeah, this is one of applications. You could say that I can parameterize it, that I want to write text at every center of an image or some other coordinate. So this appeared to be extremely useful product or the package. This one, it's a silly part. So yeah, let's rotate images. So that was more like playing with displacement. Sometimes there's functionality in Earth Engine that allows you to correct your image a little bit when you know displacement of every pixel. So you could do it, but you could go wild and then say, okay, let's take rotation metrics and recompute all coordinates, and then you can have this Benny Hill-like animation. So someone suggested, oh, you should add music to this. So that's when it started, like some years ago. It was fun. And this one is also like, I think this is more goes into advanced use of Earth Engine, what takes probably a lot of compute power, but you could use Google Earth Engine, which is a planetary scale image processing platform. It means that it can really process images at scale. And another thing what can process images at scale is GPU. So the GPUs, when they are programmed, you have to use a lot of math to let's say, simulate light. In fact, GPUs are 2D, so they are flat. You don't have 3D kind of API internally. So you express your algorithms in matrices and vectors, and then it goes into, let's say, the GPU, and then it massively scaled. And that's the same what you could do with these scripts. But I would not recommend if you don't want to really play with graphical algorithms to kind of start digging in the scripts, but you can find these examples here. And yeah, so this will be my concluding slide showing that if you would follow some computer graphics tutorials, you could do the things with Earth Engine as well. So that's, and yeah, so what this more or less explains what you have to calculate to make it working. So I think by these slides I will conclude my part and will pass.
Awesome. Thank you, Gennadii.
Thank you.
Cool. Always fun to see Gennadii's amazing work. I wanted to show a few other quick things for Earth Engine. These are actually things that Justin shared with me, so you can ask him about them. But you can bring icons in, so there's sample code for that here. Icon images. This is something you can do with some of the techniques that Gennadii showed of translating images, of moving them. In this case, we're showing a dust storm moving from the Midwest into northern Texas, and the storm stays in the middle, and the whole image moves with you. So some cool visualization techniques. Again, the code is in the slides there. This is wind particle vector stuff. So again, for inspiration, things you can do with the right data sets and the right code. And then this one is animation of burn scars, so using fade techniques to really make an animation nice and smooth and visually appealing. So a few more Earth Engine techniques that might inspire you there. So now I want to dive into how to sort of connect Earth Engine and Earth. If you were in the visualization techniques session on the first day, this is a quick summary of some of that stuff about exporting map tiles and bringing them into Earth. So I will do it very quickly. If you want more details on that, you can go back and watch the video from the Earth Engine visualization techniques session. But basically, we have some code here that brings in Landsat and does some false color visualization on it. In this case, it's California, and it's loading very slowly. Yay, live demos. Here we go. Come on. Well, I have screenshots of this, so we'll let it do its thing. I thought. Yeah, I thought. Well, I cached it this morning, and it still isn't loading fast. So I don't know. Anyway. You can see California here with some false color imagery that really makes the forests pop in green and makes the fire scars pop in those sort of brown streaks. So any image data set that you want to use here, but what this has is a way to export this. So you can use the dynamic maps that are created in Earth Engine in your code editor. You can put them into your EE apps. But if you want to put them on Google Earth or onto a website with the Maps API, or serve them somewhere to a large audience, or where you really want high performance, then making those dynamic requests to Earth Engine, as you saw, can be slow. Exporting map tiles gets you a static version of all those images at all the different zoom levels, and you can get great performance and not have to hit Earth Engine all the time. So that's what this part of the code here is for, and we will step through that in the next slide here. So you have your image that you want to export. It needs to be an image, not an image collection. That has bitten me many times. You can give it a description. That's your task name. It also gets used for the output folder if you don't provide another one. And we have to provide a bucket, a Google Cloud Storage bucket. We use storage buckets to host things that are going to be served publicly. You can't export these to Drive because Google Drive isn't really made to serve files directly. Every time you go to Drive, you get a web page with the file in it, not a direct link to the file, right? So that's why we put things in buckets, Google Cloud Storage buckets. We define our maximum zoom level that we want our tiles to go to. We define the region, the polygon that we want to export, whether that's a box or the shape of the state or whatever. And it's good practice to clip your image to that region before exporting. And then we set the tiles to public so that the right permissions are there. They can be accessed online. And I won't go into all the core stuff, but in order for something like Google Earth Web or a Maps API script to access things, they need to not only be public, but also have the right CORS header, stands for cross-origin request stuff, and it's a bunch of server security things that, unfortunately, you need to deal with when hosting tiles, and it's all in the documentation there. In fact, this link is a brand new guide on the Earth Engine documentation that just went up last week that walks you through all this tile export stuff. Here's a slide on setting up buckets. You can look at this yourself, and this walks you through sort of all the settings you need to give it a unique name and access controls and all those things. I won't go into the details here. Again, we covered that in the session on Tuesday. This is what a tile export task looks like when it's done. And just like any other task in Earth Engine that you run, except this one gives you output URLs. And here you have the Earth output URL with the $ square bracket variables that's in Earth Web. And you get the Maps URL with the curly brackets that work with the Maps API. So once we export, this is what it looks like. And you get this pyramid of tiles. The first level of folders is my zoom level. So level 0 is global, and level 0 in X, or the X0, and then I get a 0 file, and there's the whole world with my California tile in the and if I go back and go to a more reasonable zoom level, such as, let's go to level 10. And here are the X coordinates in the Google Map tile coordinate system. And maybe I'll go here. And then I get all of the file names again are the Y coordinates. In this case, because they're auto tiles, it uses PNG files where it needs transparency, partial transparency in the tile, and it uses JPEG where it's fully opaque and can have a more efficient JPEG file. But that's why you don't see the extensions on here. So let's go open one of these up, and nope, that one's blank. Poor choice, Christian. Come on. Nope. Let's choose another one. Which one did I choose? What's that? Oh yeah, look at file size. Hey, that's a good idea. Thanks, guys. File size. No, yeah, I don't want the bytes ones. I want the kilobytes ones. Let's choose one of these. There we go. There's one with some data and some transparency. So, hey, we are right. Where are we? We're right in there. Cool. So, That's what a tile set looks like. The other thing you get in your output folder is two little preview files. This index.html, if I open that up, that's just a very basic Google Maps API page. I did not provide it with my Maps API key, so it's got these watermarks that says for development only. If I provide my API key, then it will look normal. But I can zoom in here and look at all my tiles. Let's go back and look at that spot. We are right here next to that Moffett Field runway. And you can see how these tiles load super fast, right? No delay like we saw in the dynamic request to Earth Engine. The tiles are all just coming right in. We can also go to the earth.html file. Whoop, requested entity not found. What does that mean? Nope, I want, you don't want to see that. We're going to go back here. Let's go to this one. All right. So this opens it up in Earth Web, and there are tiles here as well. And you can zoom in the same way and, of course, take advantage of that awesome 3D terrain in Earth. And you can see how those tiles are draped right over the 3D terrain. So we can see where these fire scars are going up the hillsides, as fires tend to do, right? And get a lot more sort of context in the 3D world of Google Earth. So cool technique for getting large raster data sets, imagery data sets out of Earth Engine and being able to visualize them in Earth. And then David will get into some techniques for how you can tell stories with the data that you bring in. So let's see what else I have before I hand it over to him. I talked about the Maps preview and the Earth preview. Yes?
Question on the tiles. You can also load them in Earth Engine themselves or using an apps, isn't it?
Yes. The question was if you can load the tiles into Earth Engine itself. Again, the session from Tuesday covers that a bit, but these tiles, if you want to have fast loading tiles either in the code editor or in your Earth Engine app, they can be used there as well. Yeah, so you can use dynamic Earth Engine requests, or you can export to an image asset and use that as sort of an in-between, or for the fully hosted tiles, you can go with this technique and use it in Earth Engine, in Earth, in Maps, in your GIS software if it supports tiles, in your web mapping tools like Leaflet or Mapbox, things like that as well. Earth Pro does not support this type of map tile. Earth Pro uses a different tiling method called a KML super overlay that has a different projection and requires a tree of KML files to load the tiles. So there are other tools for that, but if you want to know about that, come find me later. I'm going to show real quick in Earth Web, we can also, if you have a tile set, you saw how I just clicked into that preview file, but if I want to add it to a project that I'm building in Earth, I can, why can I not edit this? Okay, create a new, let's use this untitled project, and I'll add a new tile overlay. You see how a tile overlay is one of the feature options in Earth? And if I go back to my thing here and copy that URL for my tiles, I can go in here and my tiles, and I can put the tile overlay URL into this box. And you see how it has the variables in here for the level or the zoom, the X and the Y. And the tiles should already be loaded. There they are. If I really want to do this right, I would find the bounds of my tile set and put them in here, because otherwise Earth is going to request tiles everywhere, and it'll make lots of requests for non-existent tiles. But that's a detail. Don't need to worry about too much. So this is how you can bring them into an Earth project and then do other fun stuff with them. You can also export vector data, again, from the presentation on Tuesday. Links here, and you can overlay your, for example, fire boundaries on top of your imagery and really start to get some cool visualizations, right? So I will hand it over to David to show you how some techniques for creating stories and doing cool stuff in Earth with data like this or on its own. So we're going to do a quick laptop switch.
I like the running dinosaur. I'll have to show that one to my kids when I get home, get them interested in GIS. Okay. Okay, so once you have made some really cool animations in Earth Engine and you want to have them running in Earth, I'm going to show you a little bit how to manipulate overlays from the panel code that you have control over in Earth when you make a KML story or a cloud project story, and then also how to drive with the JavaScript if you have a stack of different overlays that you want to step through to turn it into an animation. And then finally a little bit about how you do that as a cloud project as opposed to KML, because it works a little bit differently with manipulating the IDs. So I'll give you an example of from the Voyager stories first, where we use this kind of technique. So this is one of my favorite Voyager stories about this bird in India that migrates ahead of the monsoon. So we put together an animation here that's built in Earth Engine and then exported as individual image overlays, and then we drive this with a JavaScript loop in the panel here, so you can see how the monsoon moves in and how the bird migrates to be there ahead of time when the monsoon comes. So let's see. Okay, so in the panel, you have your full web developer type control over how you want things to look and work. You have your HTML, CSS, and JavaScript, and all of this. But for interfacing with the map section, we mainly have this special link mechanism that Earth provides for changing what you see on the map from the code that you have control over in the panel. So you have IDs that reference your different place marks. So in the KML code, it would look something like this. If you give your place mark a name, then you can reference it in that special formatted links that Earth will intercept when you click them. So some of these already existed back in Earth Pro, Balloon and Fly2 and these ones, and then Earth for Web adds a few new types. Teleport, you can jump directly without doing a long flying animation. And the ones that are especially useful for manipulating the overlays is the show and hide one. So I'm going to zoom in a little bit here to look at this overlay. So show and hide toggles on and off this ground overlay, which is set up the way that Christiaan showed earlier. It's a stack of tiles exported to GCS. And then when we know that we can manipulate KML pieces with those links, you can also wire JavaScript together to basically fire a show event for one piece at a time in sequence. So you could make something like this one here. This is my trip to come over here. So it's 40-something line string pieces, and we just switch on one at a time to drive the animation. And then once we're over here in San Francisco, I'll show one other type as well. There is if you add orbit after, then the camera will keep doing a nice panning animation around where we are. So let's Fly2 plus orbit. Okay, I'll jump back to the Dublin one. Teleport, boom. So here's all the different pieces of the line string, and the JavaScript runs, you can see it toggles them one at a time like that. So you could do that with, in this case, it's just line string pieces. But if you had a stack of exported overlays, you can do things like this. So I'm going to look at the JavaScript code that drives that bit. You can edit that inside of Earth here, but it's not very wide, the panels. I usually prefer to copy it out and work it in a text editor instead. So there we go. So up here this is the normal type links to toggle on and off an overlay. So they have to be set up with the ID and then semicolon and show or hide. But to drive it from JavaScript, we have an empty link here that doesn't have a target and it doesn't have any text, so it's invisible in the pop-up. It just has an ID, and then we can grab that ID from a small helper function down here, find that element, fill it with a text string, and then click on it. And then after a certain delay, do a set with this timeout here. And then this loop here steps through an array with the different IDs for all of those line string pieces, or each of your overlay stack if you want to drive through a time series of overlays. We just loop through the array, construct the show link, and then with an incremental delay, we fire this little function that will populate this link in the background invisibly and click on it. So that's when, if you build it up as a KML, that you import into Earth. But if you want a shareable link that you can send directly to people, so you don't have to send along instructions for open this KML file from the email, import it into Earth, and so on, then you want to build this up as a cloud project instead. So, and then it will work slightly differently with the IDs. So this is essentially the same file, but it is built up as a cloud project, so you can get a link. So when you create new elements in a cloud project, Earth come up with the ID by itself, so you don't get to choose what the IDs are. It's a long random string. So to grab all of those at once, we can export as a KML file, and then just look for all the place marks. That'll do. Okay, there's all my place mark IDs for the cloud project, and then we can build up the array using those ones instead. So then the code will look like this instead. So there's an array of each of the IDs from the exported file, and the clicker will step through these, and the show and hide link will look like this with those IDs instead of with the simpler ones that's in the KML file. Okay, I think that's my piece. Yeah.
All right.
Laptop, or we don't need.
We can leave it on here, I think.
Presentation
I
is
wanted
still.
to show real quick the how to find the ID of a object in a cloud project.
Oh yeah, we can do
through
it
interface.
the
Do
GUI
you
way.
want to show that real
Yeah,
quick?
you can talk and I.
You
Yeah,
drive your laptop.
yeah, gotcha.
So if you want to reference a feature, placemark or otherwise, in your cloud project, and you want to know that ID without having to download, and do the techniques
Without
that
doing
David
this
did,
stuff.
There's a simpler way to do it one at a time. So open up the balloon editor for one of, or just create a new placemark.
Yeah, new I think was easiest.
Create a new placemark
Boom, there.
anywhere. and then standard place mark here. If you click add link, click on that, and then you can link to another feature in your project. Select one of those. Click OK.
Do you want to?
Choose whichever one. Fly to the feature. Now, there is your ID. It just put it right into your balloon there. So now you know the ID, and you can use it like that as a simple link, or you can learn from David's amazing JavaScript and do it automatically and animate things. Cool. Can we go back to the presentation?
Yep, sure thing.
Great. It's slideshow.
Yeah.
Awesome. I think that is, there are some pages there that document and provide links for the things David showed, so you can reference those. And that is the end of our presentation. Yeah, we have plenty of time for questions. So we went through.
Can you use it for you?
My mic's not working. Aha. Turn it on. There we go. I was wondering about that, about my mic. Okay, can you hear me better now? Good. Great. So yes, thank you guys. Lots of fun stuff. I hope you all enjoyed that. And I'm sure I hope you have lots of questions because we've got a bunch of time. And we're happy to talk through these techniques. Or if you have other things you've been curious about, feel free to ask anything with Earth Engine or Earth or storytelling, whatever you want to do. The floor is open.
They want to hack, I think.
Yes, there's a mic here, or we can pass one around. Somebody can break the ice. Yes.
Quick question. Can we use the map tiles in Earth Studio?
Yes, the rendering engine in Earth Studio is the same one as in Earth Web and mobile. And so it does support map tile pyramids. You'll have to create a KML file that does that. Now that the tile layer exists in Earth Web, you can create it in there, export it as a KML, and that should work. I can't remember if I've actually tried that whole procedure and if there's anything broken in there, but I think that should work. Or you can. There's a way to create those KMLs by hand as well.
Yeah, I got that up on the screen here. So that's how the KML will
Oh,
need
yeah.
to look, and you can pull that straight into Studio. And in Studio, you can do some stuff you can't actually do in Earth Web. You can manipulate the opacity, so you can do a smooth fade in or fade out of the overlay. That doesn't exist in Earth Web at the moment. You can just switch it fully on or off. So
Right, here is ground overlay with the map tile pyramid section that puts in our URL here with our variables and defines some things like the minimum maximum zooms and the tile size. And then it just knows what to do with all those tiles.
yeah, that's the magic bit that's not in the KML spec yet.
Yes, that's not documented in KML yet, but you can get it out of Earth Web. Other questions? Yes. Yeah, why don't, if you can bring folks the mic, that would be great.
Now that Gennadii is internal and you can maybe start looking at some of the usage statistics for the different libraries that people are importing from the GitHub, is there any plans to make some of those, like especially the text one, fully supported Earth Engine capabilities, or is the community generally happy to just keep using these various GitHub imports?
I don't know anything about that. I'm not on the Earth Engine team and certainly not a product manager, so I'm not sure if that's anywhere on their roadmap right now. I know they have a lot of important priorities and are still finishing the cloud launch process and all that stuff. So I suspect it would be a while, but there are many features like that, and if the community really speaks up and says that that's something we really need to have built in, that's the kind of feedback that we try to listen to. Other questions? What kinds of things are you guys working on that you might want to use some of these things for.
Yeah, I do have a question.
Yeah.
I know the short answer is probably no. I want to use those exported tiles in Google Earth Pro. And I know that's not possible in the easy way, but I know there's some other people that using PHP scripts to somehow convert those tiles into something which is loadable, with slight error in projection. Is there a way to do it with these tiles as well?
Sort of. So as you said, the projection used in Earth Pro is slightly different than the one in Maps and Earth Web. So the tiles won't, they won't be quite right, but for most visualization purposes, it probably won't matter. That said, Earth Pro doesn't know what to do with just a pointer to the top of a tile pyramid, like we can give Earth Web, and it knows what to do, but Earth Pro doesn't speak tile pyramids. It speaks KML, and the way you can load a pyramid of tiles in KML is with this thing called a KML super overlay. And basically it's a set of tiles with a KML file for each one that defines which zoom levels it shows at and links to the subtiles below it in the pyramid with network links. Bunch of KML fanciness built in. There are tools out there that will generate a KML super overlay. And actually, one of the easier ones is built right into Earth Pro. So if one way you could do this without dealing with map tiles is to export a geotiff from Earth Engine. I'm not sure what the size limits are for importing into Earth Pro, but as you may know, you can import a geotiff into Earth Pro. And when you do that, it will give you if it's small enough, it'll just import it as a single ground overlay. But generally, your geotiffs out of Earth Engine are going to be pretty big. And it will give you the option to either crop it, scale it, so it'll just reduce the resolution to make it small enough for a single ground overlay, or it will give you the option to generate a KML super overlay, and it will actually dump out a folder full of images, image tiles, and KML files onto your hard drive. So it will generate that for you right in Earth Pro. So that's another way to do it. There probably are ways, as you were alluding to take your map tile pyramid that you export to GCS and have some script write the right KML files that reference those and use those tiles even though they're not quite the right projection. Does that answer the question? Yeah.
Yeah. Such a script. I'm using one that's working, but I don't own the script. So it's functioning, so I can add the regular Google Maps overlay in Google Earth Pro, which is often useful, but I'd like to use it on my custom tile. So wondering if anyone or you or any of the team has such a script available that I can point towards a custom tile set that I or someone else.
So you're generating tiles with something other than Earth Engine.
And have it on the fly so I don't have to manually import it.
But you're saying you have a script that will turn...
I don't own the script, but I'm using a script that someone else owns that overlays Google Maps tiles in Google Earth Pro, and it's working pretty well.
It's an Earth Engine script?
No.
It's separate.
PHP script.
PHP. Okay.
Yeah.
Yeah, I would have to look at details. So let's talk later.
Yeah.
But
Let's do that.
yeah. Sure. Other questions? What else do you guys want to know more about? What was your favorite demo besides the dinosaur? Yes.
The false color fire stuff was really useful to my work. Anything from fire perimeters that are up to date, which I think you have till 2021, which is pretty much what's available. Showing imagery animations of fire burning relative to certain places that we work or have treated. And then anything else kind of along those lines. So yeah, thank you for some of the case studies.
Yeah, for some more ideas along those lines, I think it was last year we gave a talk on animating a bunch of demos around fire animation. Some of it was with the GOES imagery, the geostationary satellites that are low resolution but high temporal resolution, so you get an image every 5, 10, 15 minutes, and we showed how you can animate those to show smoke movement and fire movement and things like that. So check that talk out from last year. I think it's available, or come find me if you don't find it. But yeah, there are ways to do that. We, as you may know, our crisis response team makes fire boundaries, at least in the Western U.S., available as part of the visualizations that we provide for our crisis alert information in Maps and Search. And we generate those from GOES data. So they're much lower resolution than the official boundaries that you get from the fire agencies, which are usually surveyed with infrared aerial systems and very detailed for firefighting purposes, but they only come out once a day and usually like a day or two after they've been acquired, so it's slow. We use GOES to get a very low resolution rough estimate of the fire area, but we can do it every 15 minutes, right? So it's updating very quickly, which is nice for fast moving fires. And so I believe that sample code is available, or there are talks about how that was done that you might learn from as well for using the GOES data to detect the hot pixels and generate a polygon that grows over time and animates.
Thanks,
Just a
guys.
few other ideas.
So the 2021 talk goes GOS.
GOES is GOES is the name of the geostationary satellite collection.
And there are actually two, or I believe now there are more products like that. So it's I was one time also like making animation of this forest fire with this product, and what I found, let's say, very useful is that to use any product, real-time product you can find. So try to merge both products, and also have a look on all Landsat and Sentinel optical images, because they're not frequent, but once you have one image and you merge this image collection together, you'll get you can just follow on more coarser temporal resolution the propagation of fire, but you get all the details, and combined with GOES like overall picture, you could go also wild, like use that fine resolution to refine your GOES imagery, but that's
yeah, you can combine the
goes
different
into hacking areas.
Yeah.
Thank you.
Cool. Other use cases, ideas. Sure.
Ooh, that's loud. I just wanted to say that I like the material icons slide, where you can add like the G-static images. I'd known that, but I think it's really cool to see that you can also add...
Was it these?
Yeah.
Yeah, okay.
That you can add your own images and GIFs as well.
Yep.
Yeah, just neat.
Cool.
I think
Then this rotation of images suddenly becomes interesting use case.
yeah.
And if you need my misspelled short link again for the slides, it's up there. Cool. We still have 5 minutes, so unless folks have other questions for the group, maybe we'll end a little early, get you all on your way to your next snack and coffee, etc. And we'll hang out here for a bit, and happy to answer other questions one-on-one. Sound good?
Yep.
All right.
Thank you.
Thank you, everybody.
Thank you.